Okay, I'm back, and now we want to talk about modifying the theory of solar system formation to account for migrating planets. So if you recall, when we started this unit, we began by talking about the formation of the solar system. And we said that the solar system began as this big ball of gas that collapsed because of gravity, and then as it collapsed, it began to spin, and then it flattened into a disk, and then the size of the disk stopped contracting due to centripetal force, and then because of the temperature of the sun, there was an ice line, which meant that the inner part, if you were inside the ice line, ice could not exist, so those ended up being terrestrial planets. And then outside the ice line, you had the ice, and then that formed the helped to form the Jupiter and Saturn, Uranus and Neptune. And then they also attracted hydrogen and helium gas, so they got bigger and bigger. And that was pretty much how a solar system formed. So you'd have inner terrestrial planets, and then you would have outer gas giants. And everybody was all pleased with themselves until they started looking at other planets in our galaxy, and they found that some of these gas giants were way too close to the sun. They were inside the ice line. And so that would go against the theory that they had back then of how a solar system would form. So if they were inside the ice line, they wouldn't have had the ice to be able to accumulate the gas to make a gas giant. So what we need to do is to assume that the gas giants form outside the ice line, but then somehow they move closer to the sun. Okay, so there is a video that you will find very interesting, and it's called Jupiter Destroyer or Savior. And so if you can, you should be able to find that one on the internet. And so I've provided the web address for that. And so these pictures are screenshots taken from that video. So we're going to assume that Jupiter forms outside the ice line, but it forms 1/3 closer than it is today. So it formed closer to the sun, but it was still outside the ice line. And so in that picture there, you see that swirling thing of dust and gas that's going to become Jupiter. You'll also notice that there's an awful lot of other debris in the forming solar system, so that's what's left of the original disk that formed the solar system. All right, let's take a break, and when we come back, we're going to talk about how can the distance of a one of these Jovian planets, how can it migrate? How can it move in and out of the solar system?